Hello everybody! Today we're going to practice simplifying an algebraic expression using GEMDAS. We have an example here written to the left side of the screen. It says to simplify the expression 4 minus 8 divided by the group 3 minus 2 to the second power times 5. So there's a few different operations that we see here. We can see subtraction, division, I see more subtraction, I see an exponent over here on our 2, I see multiplication, and I see a grouping with these parentheses. So there's a few different operations we have to consider, and we need to know which operations to use when trying to simplify this expression. So that's where the order of operations comes into play. We have the order of operations written here to the right. GEMDAS is a helpful acronym that we use to help us memorize the order of operations. We have GEMDAS, which starts with a G for groups, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. All of our basic operations written in an order from ascending to descending that tells us exactly which operation to use first when faced with the task of having to use more than one operation at a time. Some people here might be thinking, GEMDAS, that's new. I've heard of PEMDAS. Well, PEMDAS is very similar to GEMDAS. I like to say that PEMDAS is somewhat an outdated version of GEMDAS. PEMDAS is not as inclusive. When we use PEMDAS, the P is used instead of a G, and the P represents parentheses, which is a type of groupings, but there's other type of groupings. And so sometimes students will be utilizing an expression and they'll see some type of grouping that's not a parenthesis and they won't know what to do. And so we try to change from using PEMDAS into using GEMDAS so that students can more easily recognize, like, hey, oh, this is a group. It doesn't have to be a set of parentheses like we're used to. Maybe it could be these square brackets that we see, or maybe these absolute value bars, and so on and so on. There's many more grouping operations, but we'll just consider these few ones for now. As we're looking at our expression, I definitely see a group. Like, that's what parentheses do. They group things together, and we have to start with the group first. That's our main focus. And so I see this entire expression here, and I want to dive in, but I have to dive in inside of this group. So I'm going to ignore everything that's outside of these parentheses right now. All I see is 3 minus 2 squared. I always like to say if it doesn't change, it stays the same. We're not doing anything to this 4, so I'm just going to bring it down. This 8, haven't done anything. I still have my division sign. All we're doing is rewriting the inside of this parenthesis in a more simplified form by applying this operation that's inside of it. Now, focusing only on the inside of the parenthesis, maybe I can even color code to help it stand out a little bit more. Focusing only on this little inside, what do I see? I see it says 3 minus 2 squared, which in itself has 2 separate operations. We have the subtraction operation, but we also have the exponent operation. And so I need to know again, which one do I do first? And again, we utilize the GEMDAS so that I can figure that out. When stuck between subtraction and an exponent, we see that E is higher up on the order of operations than subtraction, which is at the bottom. And so we're going to go with exponents first. So before I even touch this 3 or anything else with the problem, I have to simplify this power here. It says 2 to the second power. We know that powers mean to multiply something times itself that many times. So 2 to the second power means I want to multiply 2 times itself 2 times. I'm not changing this 3 down here, this 3 up here, and so I'm just going to rewrite it. I still have my minus sign, I haven't changed that, but this 2 squared is no longer going to be written as 2 squared because we know that 2 squared is really just 4. And so between this first step and this second step, not much has changed. We changed one teensy-weensy thing, just simplifying this 2 squared into the 4, and the problem's that much more simpler than it was before. It's not much, but each step of the way will get a little bit closer. So let's continue. So I'm looking through my expression and I'm like, which operation should I choose next? I still see the same few operations. I have a minus, a division, another minus, a multiplication, and so on and so on. But we also have this group still. we have the group 3 minus 4, and I know that groups are at the very top of the order of operations, and so I have to do that first. I'm going to ignore the entire rest of the problem and just focus on what's inside of this group. If it doesn't change, it stays the same, and so I'm rewriting this 4. We're not even focusing on that yet. This 8 also hasn't changed, still have the division sign. All we're doing is turning what's inside of this group into whatever it simplifies into. It says 3 minus 4, and we know 3 minus 4 is -1, and so it turns into a -1 inside of that group. I haven't done anything to this 5, and so it's still going to be there because, like we said, if it doesn't change, it stays the same. Only one little thing has changed from this step to get to this step from the previous step. All I did was take this 3 minus 4 and turn it into a -1. Everything else is still the same. Let's continue. As we see, it gets a little bit more simple each step of the way. So next, what operations are we left with? I see I have a minus, I have a division symbol, and a multiplication symbol, so I need to know which one to do next. We go to our list of operations. There's no groups to consider. There's no exponents. I do see multiplication, but I also see division. And so here's the interesting thing. 2 sets of these operations on the order of operations are inverses of one another, and I'm talking about these 2, multiplication and division, and these other 2, addition and subtraction. Multiplication and division invert each other, which means I would undo multiplication with division and so on. They're the opposites of one another. The same thing goes for addition and subtraction. And so when we're dealing with an algebraic expression in which we're faced with having to do both multiplication and division in the same step, same thing goes for addition and subtraction, we actually don't follow the order of operation. We follow the order that it's written in the problem. So I see for this next step, what I mean is I have a division and I have a multiplication, and I'm wondering which one to do first. If I were following the order of operation, well, the m comes first. I would think, oh, let's do this multiplication first. But in the rare instances, if we're dealing with multiplication versus division, well, then I have to choose whatever comes first, written in the actual problem. Reading the actual problem, what do we see? Well, we see that division comes before multiplication in this problem. And so we read from left to right. I'm going to do the division operation before I do that multiplication operation. So that's kind of one of the picky parts of the order of operations, is that whenever we get to a point, it happens every now and then, where I have both multiplication and division, it's not multiplication first always, and it's not division second always. It entirely depends on how it's written in the problem. Same thing goes for addition and subtraction. If I have them both in the same problem and I need to know which one to do first, it depends on which one comes first. And so let's go back to the problem now. I think and hope that we all agree now why I'm going to do this division operation next instead of the multiplication operation, because they're inverses, and so I have to use the first one that I see, which happens to be division. Nothing else in the problem is changing, so I'm going to rewrite it. The 4 stays the same. I still have this minus here. All we're about to do right now is this part here that says 8 divided by -1. I want to know what's 8 divided by -1. Well, I know 8 divided by +1 is +8. So 8 divided by -1 must be -8. So I'm just going to write that -8 here. There's still that 5 there. It hasn't changed, so it stays the same. I'm just going to bring it down. And so now I see there's a little bit more to simplify. But we're getting closer. Like, this is much more simple than it was to start off with. But let's see what operations we have next. So we have subtraction and we have multiplication. Those are definitely not inverse operations. So I'm going to do whichever comes first in the order of operations. And I see that that is multiplication. So let's dive into this multiplication. It looks like we have -8 times +5. -8 times +5, that's just -40. I'm going to bring down this 4. It still hasn't changed. We haven't touched this 4 once. Sometimes that happens. I'm going to bring down this minus. It still hasn't done anything as well. But this -8 times 5 turns into -40. And so the problem's much simpler. There's only one more step that we have to do. I do see a double negative, and we know double negatives can come together to make a positive. I can write it like that, or if we don't like skipping steps, we can just rewrite it as 4 plus 40. And 4 plus 40, of course, that's just 44. And so we simplified this algebraic expression. While doing so, we ended up with something that it was, of course, more simple. If all of this is really just equal to 44, then why wouldn't we want it written as 44? That's the whole point and purpose behind simplification, is it's much easier to call all of this the number 44 than it would be to call it 4 minus 8 divided by the group 3 minus 2 squared times 5.